Alright everyone, this is the second to last of the videos in this unit. Both of these last two videos deal with multiplying polynomials. This first one we're going to start off a little more basic, and then the second video will be a little bit more complex. We're going to see some of those special cases. So if you look ahead, you can see that we've got a single term times a binomial here in this case. You might see this and think, well, we already know how to do this, how to multiply this, right? You would just take that first term and distribute it into each of the terms inside of the parentheses. And that's right, that's exactly what we do. So to write it out, we want to distribute any coefficients. And as a reminder, the coefficient is the number in front of the variable. So we want to distribute any coefficients and the variables to the polynomial inside the parentheses. As a reminder, our coefficients, we're going to multiply those together. So we multiply numbers with numbers, and we multiply variables with variables. So we multiply the numbers. But what happens when we multiply exponents? When we multiply exponents, remember that if we have a to the n times a to the m, we get a to the n plus m. So remember, we multiply the numbers, we will add the exponents. Alright, so let's practice. Of course, we distribute that term out in front into each of the terms inside the parentheses. So we multiply the coefficients, the numbers in front. Remember this h cubed, the number in front, you can think of it as 1h cubed. So we multiply negative 4 times 1 is just negative 4. And then we multiply the variables, h times h cubed. Well, the exponent on this first h, since there's nothing written, we can think of it as 1. So we have h to the 1 plus 3. Negative 4 times negative 6 is a positive 24. And h to the 1 times h to the 1 is h to the 1 plus 1. We can simplify those exponents, and we have negative 4 h to the 4th plus 24 h squared. And that is our solution. Looking at this one here, we're going to take this and distribute it to each of the terms on the inside. So the exponent here is h to the 1, and the coefficient is 1. There's nothing in front of there. So anytime there's no coefficient, there's no exponent, both of those can just be 1. So 1 times 5 is 5. H to the 1 times h to the 3 is h to the 4th. 1 times negative 2 is negative 2. H to the 1 plus 2 is h cubed, plus 1 times 1, which is 1. H to the 1 times h to the 1 is h to the 1 plus 1, or h squared. We can move them to the other side of the parentheses, but we're still multiplying. So you can still distribute these to both of the terms. So we have 2 times 3, which is 6. A times a to the 4th is a to the 1 plus 4, or a to the 5th. Negative 2 times 2 is negative 4. And there's no a here, so this could be like a to the 0. So a to the 0 times a to the 1 is just a to the 1. You can also just write this as minus 4a. And you don't have to write the 1 in the exponent. We're going to distribute this to each term. So 5 times 1 is 5. C squared times c cubed is c to the 2 plus 3, or c to the 5th. 5 times 4 is 20. And then here, remember, we don't have the same base. We have c squared and we have d to the 1. We don't have the same base, so we cannot add those exponents. Remember, in order to add the exponents, we must have the same base. So we just leave it as is. C to the second power, d to the first power. And that is our solution. We're going to talk about another kind of multiplying polynomials. Particularly, we're going to talk about multiplying two binomials. So as a reminder, a binomial is a polynomial with two terms. So in order to multiply two binomials, we use the FOIL method. That's F-O-I-L. We use the FOIL method. And what FOIL stands for, it's an acronym. What FOIL stands for is first, outer, inner, last. And this is how we can multiply two binomials. So, for example, if I have a binomial a plus b times another binomial c plus d, then we start by multiplying the first term in each binomial. So we multiply a times c, that first term in each of the binomials. A times c is ac. Next, we do the outer terms. So a times d, the two outer terms. So we have plus a times d. Next up is I in FOIL, the inner terms, so b times c. So we have plus b times c. And finally, we have the last terms in each of our binomials. So that's going to be b and d. So plus b times d. This is the FOIL method. First, outer, inner, last. Now, anytime you multiply binomials, you get an expression. Anytime you have an expression, we always want to simplify and combine like terms. So after you FOIL, then combine like terms. In this example, we don't have any like terms, but we'll see in some of these examples below that we'll have like terms that we'll need to combine. So let's practice using the FOIL method. So again, FOIL, first, outer, inner, last. We're going to start with first. So we multiply the first terms in each of these. So we have x times x, or x to the 1 times x to the 1. So that would be x to the 1 plus 1, or x to the second power. Then we do our outer term. So x times negative 2. Keep in mind we are multiplying by negative. So x times negative 2 is negative 2x. Then we multiply our inner term. 4 times x is positive 4x. And then we multiply our last term. Oops, forgot the green. Here we go. Then we multiply our last terms. 4 times negative 2 is negative 8. Now we see here that we must combine like terms. Looking at this here, we have like terms. Remember, like terms have the same variable and the same exponent. We've got a negative 2x and a positive 4x that we can combine. So when we combine those, we have negative 2 plus 4 is a positive 2x. And then we bring down the rest. And that's our solution. Let's try another. Let's use the FOIL method. So we have first, y to the 1 times y to the 1 is y to the 1 plus 1, or y squared. Outer, y times 8 is a positive 8y. Inner, 5 times y is a positive 5y. And last, 5 times 8, which is a positive 40. Again, we combine like terms. We've got a positive 8y and a positive 5y. So we have y squared plus 13y plus 40. Here we have first, outer, inner, last again. So first we have z times positive 4. So 4z. The outer term, we have z times negative z. So we have negative z to the 1 plus 1. And then our inner term, 11 times 4. So we have a positive 44. And then our last term, 11 times negative z, is a negative 11z. Combining like terms, we have a 4z and a negative 11z. Those combine to get a negative 7z. Now, I like to write these polynomials in descending power order. So we write the largest power on the left, and we descend until we hit the smallest power on the right. So in other words, this has power 2, this is power 1, and 0. So this is our final solution. The last one here, again, first, outer, inner, last. First, we have 4a times 5. Numbers with numbers, variables with variables. So 4 times 5 is 20a. Outer, we have 4a times negative a gives us a negative 4a squared. Inner, we have 3 times 5 gives us a positive 15. And last, we have a 3 times negative a gives us a negative 3a. Combine like terms, 20a and negative 3a gives us 17a. And then we write our terms in descending power order. So we have negative 4a squared plus 17a plus 15. And that's our final solution. This is objective 48.